This test provides an overview of the citrate test. The citrate test, or Simmons citrate agar, has no glucose or lactose. Instead, citrate is provided, and the test is to determine if organisms can catabolize citrate and break it down, and you'll, as a result, see a color change based on the components in the medium. The indicator in this test is bromothymol blue. It's your pH indicator, and it's going to turn a bright blue color, which indicates that the pH has actually gone up in this case, producing alkaline end products. So your pH indicator or color indicator in this case is bromothymol blue. It also uses an ammonium compound as a nitrogen source as well. If the organism is unable to use citrate, the test will remain at the same color. So here you see here, this is actually a negative result, and it is a blue-green color, so it's important that you compare these two tests together, a negative against a positive, with two different organisms to really determine and see the color change. If the citrate is present, the pH will go up above 7.6, which is due to the end product, which is a carbonate alkaline end product. I mentioned earlier the alkaline end products that are produced. That will cause the bromothymol blue to actually turn a bright blue, which you see here. Now, I wanted to talk a little bit about the two color changes in this video. At the very top here, you can see the bright blue. That indicates a positive result and indicates that the pH went up. At the bottom, actually, you see what looks to appear to be a negative result. This difference is based on the type of inoculating technique that's used. If you use strictly a fishtail technique, as we do with many solid slants, you really only deposit the organism up near the top. And as a result, you're only going to see the color change where the organism is present. It's not present here down below, and so you can compare the two together, which is one nice feature of strictly using the fishtail technique. The other argument is the other technique is to use a fishtail technique and then stab it with the needle. If you do that, what would happen in that case is this bright blue color would extend all the way down to the bottom. Now, the argument here is that it's easier to read in some senses because you see the blue color change all the way through, and it's a definitive positive. However, by doing that, you wouldn't have the two different colors to compare. So here you can clearly see what it looks like when you do not have citrate fermentation, which is only the case because the organism's not down in the bottom of the tube, versus the top portion where you do have citrate fermentation. So you always want to check with your instructor to determine what is the best technique or what they recommend. May not be quite one right answer. If the organism is positive for this test, it indicates that they have two enzymes, citrase and citrate permease, which allow the organism again to catabolize citrate and use it as an energy source. And that is an overview of the citrate test. Again, it's not necessary that you memorize individual results of organisms, but you should get a sense of what organisms are easily distinguished by this test. And you can do that by looking at your gram-negative key in your lab textbook. And that's the overview of the citrate test.